Alright, so the next question reads, how do you write a third degree polynomial with zeros, -2 with multiplicity 2, and 4 with multiplicity of 1? Okay, so first of all, we need to define what a third degree polynomial is. And it's basically a polynomial with the max power of 3. So it'll be ax cubed plus bx squared plus cx plus d. Okay, where the maximum, I guess, degree or power is 3. So that's what you call a third degree polynomial. You can have different coefficients or different terms not in the polynomial itself, but this is the general form. Okay, so the question gave us the zeros and the multiplicity of those zeros, and they asked us to find a third degree polynomial. So in previous sessions, I talked about the factors, right? So I talked about how, I guess, for a 2 degree polynomial, the factors can be like ax plus b. So this is the factored form, right? Cx plus d. So the multiplicity relates to how many, the power of each of these factors. In this case, the multiplicity of these two factors are 1 and 1. Okay? Now, if we were to have a third degree polynomial, right? Let's say like this, and the factored form has a form like this. The multiplicity of this first term is actually 2, because the factored is being squared, right? So the multiplicity is 2, and the multiplicity for this is 1. Now, a good rule of thumb when you're considering multiplicities is that the addition of the multiplicities of all the factors should relate to what degree polynomial it is, okay? And that's why you never see any, that's why in this case, the only 2 different multiplicities is either you have this, where you have multiplicities of 1, or you have just this, which has a multiplicity of 2. Because it's a second degree polynomial, so the multiplicities can only equal to 2. So you have either 1 plus 1, or you have 2. In this case, you can have 2 and 1, you can have 1, 1, 1, you can have 1 and 2. It really doesn't matter, right? So going back to our original question here, so they gave us the zeros, right? Which is -2 with multiplicity of 2. Right, so we know that the first zero of -2 will be squared, right? So if the 0 is equal to -2, the factor will then be x plus 2, right? Because when x is equal to -2, or the 0, it's equal to 0. So this is our first factor, x plus 2. All right, so if the 0 is equal to 4, the factor will then equal to x minus 4, right? Because when x equals to 4, this factor equals 0, and that is equal to our 0, right? So now we need to consider the multiplicities, right? So our first factor has a multiplicity of 2, and our second one has a multiplicity of 1. So therefore, our function f of x will be x plus 2 squared times x minus 4. Okay? So this is the factored form. They want the third degree polynomial, so we're going to give it to them. All right, so we're going to need to expand our first bracket, so we're going to use the FOIL method here. I'm not going to go too much into detail about it, but it's going to be x squared plus 4x plus 4 times x minus 4. And then we're going to expand, right? So we're going to have x squared times x minus 4 times x squared. So when you get to these trinomials times a binomial, you really can't use the FOIL method anymore. So think of it more like you're multiplying each of the terms in the first bracket by all the terms in the second bracket, right? So I multiply x squared by x and x squared to -4. Same thing with 4x. We're going to multiply 4x to x and 4x to -4. Finally, we're going to multiply 4 to x and 4 to -4. Alright, and if we were to calculate all this, it'll be -4x squared plus 4x squared plus -16 minus -16x plus 4x minus -16. Okay? So these obviously cancel out if we simplify, so we get x cubed minus 12x minus 16 as our third degree polynomial. Okay? So that's what multiplicity means, and from that, from the zeros and multiplicities, we're able to find the full form of the polynomial itself. Alright, and one final note, I'm just going to highlight again, that the multiplicities of your factors, when they added together, should equal the degree polynomial. So if you had a 7th degree polynomial, you best bet that all your factors add to a multiplicity of 7. Okay? So this solution is correct. Good work. Nice. Alright, final question of the day. And it reads,